Hi everyone, this is Aisha. I hope you're doing well. This is just a small recorded tutorial for C++ pointers, only because this is such an important topic and we think that it's just something you'll be coming up back to very often in this course. All your future assignments are going to have it, so might as well get your concepts cleared out from the get-go. And I'll be uploading this file on LMS soon. It has some additional examples as well. So what I'm going to be covering is just memory accessing and pointers. But the file, I think it has C++ basics as well. So I highly recommend playing around with them, get yourself familiarized before the assignments stump you. And yeah, let's start. So starting off, we have these two functions, pass by value and pass by reference. And these really lay down the concepts of why it's so important to understand how memory works in C++, because we have in line 21, we have a pass by value function that receives an instance of an integer and another integer, and it increments them. And pass by reference also receives them, but in a peculiar way. So what this is the address of operator. So it's receiving the address of A, and here it's receiving a pointer. It's also incrementing the dereference value of B, and it's incrementing the value of A. So we'll try to understand what this exactly means in a bit. But let's see why this function is needed in the very first place. So when we call this function, right, and we've declared two variables here, variable 1 is 10 and 2 is 20. So we obviously expect that variable 1, if we pass it through this function, we get the value 11 and 21. But this is not exactly what happens. Just to give you an example output. So I'm sorry, I'm getting some extra uncommented outputs as well. But here we got variable 1 is 10 and variable 2 is 20. So why is this happening? To understand this, we can sort of imagine memory being like a long, solid block and comprised of very small chunks of memory. And when we assign variable 1 a specific value, we're saying that, oh, this is your memory location. This is how much space you can occupy, and this is the value that you put in it. So I'm assigning all these different things just by writing the line int variable 1 is equal to 10. And what essentially pass by value is doing is it's not really looking at replacing the value inside that specific memory chunk where variable 1 is stored. It's just concerned with extracting the value of variable 1, which is 10, and extracting the value of variable 2, which is 20, and doing its manipulation to it accordingly. So here in the scope of this specific function, if we look at it, it's just concerned with sort of taking the value of A, which is 10, and B, which is 20, and doing its own operations on it. And inside its scope, if we sort of uncomment this cout line, we are going to get 11 here. So this is because inside the scope of its own function, for as far as it knows, the value of A has been incremented. But the memory location doesn't exactly reflect that, because we didn't really care about the memory location. We didn't really pay heed to what the memory location was going under once we just incremented the value of A. But essentially, what we did was we just extracted the value of A. We did nothing with the original value of A. We essentially made a copy of it. We did our manipulations on it, and we handled it the way we wanted to, and nothing happened to the original location of variable A. So this is why we need to use pass by reference. So what essentially I do is, and this is just the syntax, you pass variable 1, and here, instead of declaring it as int A, you declare it as int address of A. So even if when you pass an int of A, it essentially knows with this operator that the address of A is being passed, and the function knows that the value inside this space, which is obviously 10, which is obviously 10, that needs to be incremented. So what pass by reference does, it essentially takes into account what changes will be made inside that memory chunk itself. So if we print this out, variable one, and this is also essentially doing the same thing. Here we just sent in the address of var2, and here we dereferenced it using this. And this also expected a sort of input of an address per se. So it's expecting the address of int b itself. And so we dereference b because we got an address value, and then we incremented it. So this is essentially doing the same thing as this. And I can comment this for you. So an input of var gets translated, and an argument of a. And if you sort of increment a plus plus, you can handle memory efficiently. And this is the same thing as passing the address of var, and your argument can be your pointer to b, or pointer to that specific location, and then you just dereference that pointer. And you increment it. And this also handles the issue of memory and scope. So if we print this out, we get, yeah. So here through pass by reference, we can see that our value is incremented. So this is exactly what we wanted. And obviously we can use pass by value for some functions as well. Obviously they have their own sort of requirements and own advantages. For example, if I'm a store manager and I want to update a specific price of a shirt, I'll obviously need a pass by reference, since I need the location of where my shirt's price is stored, and then I need to update it. But a customer, for example, might not want to update that shirt's price. It just needs it to calculate the tax it needs to pay. So for it, the memory location of where that shirt's price is stored is completely useless. So they have their own benefits and they have their own disadvantages as well. But you need to know like what the difference between the two is and where to use what. And this is just a very basic intro into what pointers really do. And here we have another example, and this is how you syntactically sort of assign a pointer. So you have an int var is equal to 10, and you have an int pointer, and please pay attention to this int here and int here, since this is important, because you can't assign a char pointer to an int data type. So this will show up as an error soon. Exactly. So int pointer, which points to the address of variable, which is 10. And if we print out ptr, let me just comment this out actually for you. So we get this random value, random numbers. We don't really need them. We don't really care about them. It's just the memory address of pointer one. So sorry, variable, just variable, which is equal to 10. And we're not really concerned with this. Obviously, we literally don't know and care about what happens to the memory value itself. We actually want the value that's stored inside this memory location. So if we dereference this using the dereferencing operator, we get the value of 10. So this is an important chunk to remember. And here we're just doing something very similar. So here you can notice that since we have a char var4, we're using a char pointer for it as well. And if we print this all out, let me just comment this. So now we assigned pointer 1 to variable 3, to the address of variable 3. So pointer 1 now points to the address location of variable 3. And if we were to dereference pointer 1 using the dereferencing operator, we'd get back the value 35. And we'll notice that when we come to this line, but just looking at this one, we see outed ptr1, which is equal to PTR1 right here, which is, as we expected, a memory location that we don't really care about. PTR2 is also a pointer that points to a char data type instead, which is just A. So हमने ये किया, तो we just got another sort of garbage value. Don't really care about what happens here, honestly. And we can notice that here as well. And this is also something to point out, that when you have a char pointer that points to a specific value, you need to make sure to use void here. And I'll explain why in a bit, but the gist of it is that in C++, if you look at a array, so if you have a list of numbers 1, 2, 3, sorry, it has to be a something like hello would be stored like this. And this is an array, right? But essentially it's a char array. Just imagine I wrote the O here. This is too painstaking. But this is a char array, right? And if we pass, obviously, we start off with this value. This points to H. So whenever it comes across a char pointer, it assumes that there's a string at the end of it. And you delimit using this at the end. Don't forget that. But the point is that you can get some garbage values when you use char dereferencing. Instead, just use void dereferencing. It's more general, and void is basically like a general data type. It can be anything. So just a small reminder for that. And yeah, so we were talking about how PTR1, PTR2, and these char star pointer 2 sort of lead us to garbage values that we don't really care about. But once we dereference them, we can get pointer 1 value, which is 35, and pointer 2 value, which is A. So this is exactly what we wanted. Moving on to incrementing. So this is a fun piece of code as well. So if we have pointer 1 defined here, and we want to sort of see how it increments here. And what we're doing here is obviously just printing out the original memory locations of pointer 1 and pointer 2. Let me just, we aren't really concerned with this, for now. So pay close attention to what these are, right? And if we increment pointer 2, right, we can see the change in this, right? So right here, we incremented pointer 2, and also in the cout statement, we incremented pointer 1. And our sort of pointer location changed. It's going to point to the next character now, and you can actually check the difference between them if you're confused. But it's just going to be a difference of 1 char, and or 1 pointer index. And basically, it's going to point to the next character. And if we decrement this using minus minus pointer 1 and minus minus pointer 2, it's going to come back to this. Let me see out this for you as well, so you understand what's going on. Right here. So we incremented it and we decremented it. So this is something that is a valid operation. And as you can see, we got the same values back again. इसके अंदर बस एक char का difference है here and here, because char is just 1 pointer location. So you essentially go back here and then add to here and then go back here. So this is all valid pointer arithmetic. But if you dereference it, this completely shows a different output, as you can see. Aage paas pehle you had, if you dereferenced pointer 1, you had 35, and dereferencing pointer 2, you had A. But if you added and incremented pointer 1 ki dereference value, and you check it here, it comes out to be 35. So this is also valid pointer arithmetic. So you just dereference it, you add it, and uski memory mein safely uski nayi value upload ho jayegi. And here, as I said, iske andar bas ek pointer add hota hai, and this results in B, because char ke andar ek ka difference hota hai har ek mein. So if you increment it A by 1, it's going to result in B. So just a fun little tidbit. But yeah, so I hope this was clear. Okay, incrementing pointer, the memory location itself, and incrementing the value pointed to. These are different things. So you can either do this and you can either do this, but these are not the same things. Right. Moving on to assignment after dereferencing. Okay. So we have these two int pointers. And this is also a way of assigning a new pointer without making it point to anything for now. So what we're basically saying is that there's this memory location that we stored a new memory chunk for, and we're expecting a value to be assigned to it soon, which we do right here. So pointer 3 is assigned a value of 15, or pointer 4 ko 20 mil jata hai. And now what we do is we just dereference pointer 3 and we assign it क्या कहते हैं, the dereference value of pointer 4. Let's see what happens to pointer 3 and pointer 4 now. Right. So essentially cout statement says कि pointer 3 pointer 4 से equate हो रहा है, and pointer 3 की value ये आ रही है, and pointer 4 की value ये आ रही है. So the memory location might be different, but we're not assigning one memory location to the other, right? Lekin what's happening now is the value pointed to by pointer 3 now becomes the same value that pointer 4 is pointing to. So these two different memory locations hold the same instance now because you dereferenced them and you pointed and you assigned it the same dereference value of pointer 4. So this is also important. Now moving on, we can also do this with char right here. Yeah. अगर मैं इसको भी ऐसे ही like handle करूँ, you can just see here, memory location different है, but since I assigned the dereference value of pointer 5, pointer 6 to pointer 5, उसकी value same हो गई है, but the pointer itself is different. Different memory locations पे वो same चीज रखी हुई है because we dereferenced it and then we assigned it the dereference value of another char pointer. So this is also as expected. हमें यही पता था कि different memory locations can hold different values. Like if you dereference them and assign them that specific value, you're basically equating the value that's in it. You're not equating the pointer itself. Now, with this becomes the problem of a dangling pointer. So a dangling pointer could be thought of as this, that we have a pointer 3, which is initialized as a new integer. So again, we're sort of assigning a new memory location to this specific pointer. And we're saying the pointer 3 now points to 55. So the value in it is 55. And if we print this out, we get pointer 3 as this specific memory location, and jaise expected tha, we got 55 as the dereference value of pointer 3. अब मैंने क्या किया, मैंने pointer 4 को ना equate कर दिया to pointer 3. Now this is completely different from what we did here. We dereferenced them and equated them. लेकिन इधर मैंने memory location को ही same कर दिया. So pointer 4 is now equal to pointer 3. उसकी same value हो गई है, right? So now pointer 4 points to the same memory location that pointer 3 points to. अब मैंने क्या किया, मैंने delete कर दिया pointer 4 को. So I completely eradicated the thing that was stored in pointer 4. So this is obviously a problem because pointer 3, जो जिसको point करा था, now that's completely gone. That data is completely gone. And now we can see that from our cout statements. If we cout pointer 3 and pointer 4, इसकी value specific आएगी, and pointer 3 and pointer 4 are going to give garbage values. Yeah. So pointer 3 and pointer 4 की value equate हो गई है, and pointer 3 की 0 होगी and pointer 4 की 0. This is just a Mac specific thing, but if you were to run it on your machine, this would give, yeah. So Macs are very good at, I think, memory handling. So if you were to run this on your machine or any, I think, Windows machine, तो आपको null junk values ही मिलनी थी. Yeah. So moving on, and you can test this out on your computer, by the way, as well. Let's talk about const and constant pointers, something that's also going to help you deal with ambiguity. So const essentially means that this is a variable that we need to stay the same. So we don't really want any changes made to it. अगर मैं इसको const को 20 से assign करूँगी, this is going to give an error. Just give it a second. Yeah. So your expression must be a modifier L value. This is going to show up here as well, because you can't assign a new value to a constant int. And here we're getting the error. A constant int pointer cannot be used to initialize an entity of type int pointer. So how do you fix this? What essentially we do is we assign it to a constant int pointer itself, instead of saying कि हम एक int pointer को use करें, because this is modifiable as well. So this can point to something else. But अगर हम एक constant int pointer को use करें to point to a constant variable और उसकी memory location को हम point करें और its address को point करें, then we won't get an error. And now if we try to change this, again, we get an error, which is exactly what we want. We don't want it to be modifiable. Now we have these non-constant values. अब मैंने इसको assign किया constant int pointer को to a non-constant value, which is fine. You don't get an error. And you won't get an error either if you change the value of this non-const value. It's just a pointer that is not going to change. And if you try to change the value of the pointer this way, this is going to give an error. So अगर एक constant pointer को use करके you're trying to change a value of anything, it's gonna give you an error, whether the value itself is a constant or a non-constant. Right. So I hope this clears another basic operation up. And going to arrays, I'll be stopping this meeting and for a bit because I need to charge my laptop, and I'll be restarting it again. So there might be a pause in the middle, but yeah. Moving on to arrays. Right. So let me just comment this line above because it's constantly being printed. Yeah. If we come here, we can see मैंने एक int array बनाया है, ठीक है, of 5 member variables. अब मैं जब a को print करने की कोशिश करूंगी, I expect कि मुझे 1 मिल जाएगा, but that's not true because this is just the starting memory location of this specific place. Or if I print this out, I'll get this specific memory location of where int is stored. But as I said ऊपर, if the compiler notices कि 4 pointer से कुछ शुरू हो रहा है, it sort of expects a string to be at the end of it. So अगर मैं b को करूँगी ना print, it's gonna say, okay, I need to look for the delimiting character and I need to keep printing something until वो delimiting character नहीं मिलता. So that's why it prints out A, B, C, D. So this is very important. Please don't forget this. And this only holds true for char arrays, by the way. लेकिन अगर मैं इसको इस तरह करूँगी, I reference the first index. So I get A and B. So this is obviously different. But char array को expect नहीं कर रहा, it's expecting a specific char value here. You can see here as well, it's constant char. And here it's char array, which is a char pointer. Now moving on to this, we can also see the difference in this. If we dereference A, we get 1, which is obviously the first. पहले इसकी memory location वो print कर रहा था 1 की, पहले array की value की. Now it's printing the value that's in the first memory location. So it's printing 1. And as expected for B, हमें पहले से ही पता था कि it was going to print out A. Now if we print out the A1, B1 values, we get A is equal to 2 and B is equal to B1 is equal to B, which is obviously, this is very clear कि क्यों होगा. But what would happen if we were to dereference and then add? So now what we can see is कि हमारे पास एक pointer था, which is A का first address. इसके अंदर मैंने 1 डाला and then I dereferenced it. So basically I'm going to the next memory location, ठीक है, मैंने pointer की next memory location में गई और मैंने इसको dereference कर दिया. That's why I get 2 here. So this is how pointer arithmetic works कि आप you take the first memory location, you add to the step size कि आपको कौन से step पे आपने जाना है, and then you dereference it all and you get the specific value of the needed value index in the array. And you do the same for B. You can just add a value of 1 and dereference it and you'll get B here. And obviously pointer में एक specific add करना, we know the size of int and char is different. The int is I think 4 and char is 1. So if the compiler knows कि अगर मैं कह रही हूँ ना कि int pointer में अगर मैंने 1 डालना है, that means कि मैंने 4 memory locations आगे जाना है, right? And we can see that here. I could show you. C out A1 and then A. So इसके अंदर 4 का difference होगा, as you can see, because the compiler knows कि if we're talking about an int pointer, ठीक है, that means कि since int का size 4 है और मेरी I'm pointing to a memory location that's here, ठीक है, sorry, here, since this is the smaller one. अब मैंने next pointer पे जाना है. If I add 1, obviously the code means to go to the next pointer location, right? So it moves up 4 spaces and goes to the next integer. But for the char, जिसका size is 1, if you print out the value of B versus B plus 1, you get only a difference of 1 because that's the size of it. Oh, sorry. Oh yeah, it sort of understood this as a whoa. Let me just put it in line here. Yeah, so B पे it understood कि I have to traverse the whole array, ठीक है? It went from here to here. इसके अंदर एक का ही difference था. So I hope I wish there was a way of seeing the exact memory location क्या है, but as I said कि C++ जो है, when it encounters the char array, since these are both char pointers, it assumes कि end पे उसकी एक string चल रहा है. So it looks for the delimiting character और तब तक वो print करता रहता है. So this is a good reminder of how different char and int were in C++. So I hope this was a good starter. I'll be going over some extra functions in the next video. So be sure to go over that as well.